everyone. So today I would like to show you how to create a procedural dungeon, specifically for roguelike dungeons, using Houdini today. And here's what we're gonna make today. So we have parameters like the minimum size of the room, both width and height, and the maximum size of the room, and number of grid on X direction and number of grid on Y direction, and also some number of iterations, how many rooms be placed in the grid. Like if it's small numbers, then small number of rooms will be placed, and if it's really high, the grid will be packed with a lot of room squares. And also we have the random seed to generate random kinds of dungeons. And last of all, the last parameter, it is a parameter to cut the dead end street or dead end path like this. So if it's 0, then the path is not trimmed out, but if you increase the numbers, if you increase the value, then the dead end, the path that has dead end will be trimmed out like this. So this is what we're gonna make today, and the algorithm that I use today is based on an algorithm made by some game programmer called Bob Nystrom, and he wrote an article on 2014 December 21st, so it's pretty much like 5 years ago or 6 years ago, 5 or 6 years ago, and he wrote a great article how you could create this kind of procedural roguelike dungeons using the rooms and mazes method that he came up with. And he explained how to implement this procedural dungeon one by one here in detail. So if you're interested in, I strongly recommend looking at his article. I'm gonna post the link to the description of this video, and please check it out. And I am going to follow this algorithm, exactly this algorithm, to create the dungeons using Houdini today. So let's try to do that. Before getting into the actual creation using Houdini, I would like to briefly explain the algorithm which is used for this procedural dungeon creation. So it's gonna be a really brief one, and I will explain the detail for each step later on while making in Houdini. So keep that in mind. Okay, so the first of all, you have to make some random rooms in a specified grid, the specified size of grid. And after you create some random number of rooms, you create this maze pattern on the leftover spaces like this. Then after that, connect each room with those paths or maze paths, or connect with other rooms like this, so that each room should be connected or should be accessible from any other rooms. So every room should be accessible from everywhere, anywhere. And last of all, after you have created the connection for each room, you trim out the maze passes. You trim out the dead end part of the paths like this. So if you have a dead end path like these one, then you want to trim out to create this kind of procedural dungeon. Now, Bob Nystrom is also mentioning that trimming out every dead end might be too artificial. He also he suggests that keeping some dead end paths will be more natural in order to create it as a natural procedural dungeon. So I am also going to implement that part as well later on, so that you can control how much you want to trim out the dead end paths. So that's the really brief description of this algorithm. I'm gonna explain step by step how to create this using Houdini. Now for the first step, it's we're going to create a grid that we are going to use it for the procedural dungeon's base shape. And each cell will be stand for either walls, floor, or entrance door, which connects rooms or room and paths. And it is a good idea to set the size of the room on room or the base shape, the grid size, to using a odd numbers for X direction and Y direction, like shown in this sketch. Now the reason is because if you have a even number for the either for the grid size or the room size, let's say this is the room floor and this is the wall that connects, which closes the room, then you have this leftover places, and you might want to use these empty spaces, this white grid cells, as a path. But the problem is that if it's a even number, then you cannot like fulfill the whole places with the pass, but you might going to get the double sized walls at some point. So let's try making some random passes like this. So let's say the pass should always have the width of one cells, and if this is gonna be the pass, then the other empty spaces should be wall like this. Now the problem here is that you will have those double sized wall like this if you're using a odd number of rooms here. So that's kind of a reason why it's a good idea to keep the whole grid size a odd number for X and Y, and also for the room as well. So if you keep the room size like odd numbers like this, then the wall should be like this, and all the other leftover places could be used as a path, or maybe even if you want to close the path at some point, you still wouldn't get any double sized wall. So that's kind of a reason why I would like to keep the grid size X and Y to a odd number. So keep that in mind, and let's create the base shape first. Okay. Now let's go back to the Houdini and let's try making some grid inside the empty geo. So first I'm gonna create a grid. Then let's set the sizes, and in order to set the size I would like to change the sizes afterwards using parameters. So I'm gonna create a null node as well, which to store all the parameters that I want to control. So, and I'm gonna name this controller, call it this so that I can see it clearly. And okay, let's start having parameter called gridx, which stands for the size of the grid on x direction. And let's keep the range from, I don't know, 1 to 100. Although the 100 is a even number, so either 99 or 101 should be used. But I am going to create some expression later on in order to change the chosen value into a odd number. So I'm gonna do nothing for this at this point. And I have grid y for the y size on the y direction, from range from 1 to 100, right? Y. And also let's have some minimum maximum size for the room. So min size, and as I said, the size should be either, the size should be a odd number for the room as well. So I'll set the range from 3 and maybe to 21. Okay, and another one, max size for the room. Since I'm gonna choose the size of the room randomly using some random seed, and from this one as well, from 3 to 21. Okay, apply. Okay, let's start making it by setting some parameter here. Right. Now, I want to use those grid X and grid Y in order to control the number of cells and the size of this grid. So let's do that first. Okay, so I'm gonna just use some expressions here. First of all, I'm gonna set the rows, number of rows and number of columns using those parameters. And sometimes, as you can see, sometimes by changing these parameters, sliders, you sometimes get the even numbers or odd numbers, and you always want to have a odd numbers as a result for the X and Y cell numbers. So I have to do some expressions in order to change the value into a odd number, even if you have an even number here. So let's copy this parameter first at grid Y and go to a grid and paste this using paste relative reference here. And at this point you all have a direct number 46 here, but this is an even number, so I want to change it to a odd number. So in order to do that, what I could do is I could maybe multiply it, or multiply it and do 1 plus 1 modular 2. And that way, okay, I have some problem here. Did it say 92? Okay, it's not good. That is not good. Okay, let me change the equations. So I'm just gonna directly copy this expressions and plus same parameter modular by 2. Now this will give me a result Okay, still. Okay. Well, it's okay to have this one be even numbers, because if you have this as an even number, then the actual number at the row, actual number of rows, actual number of cells is actually a odd numbers. So try checking out by decreasing the number, something like 4. And as you can see, the rows here, it means it's just a number of points here. So 1, 2, 3, 4, but the actual cell number is 3, so that is fine. So that's fine for the y direction, and do the same thing for the x. So copy this parameter and paste it at the column parameter here, and do the same expression plus modular 2. Now you have both even numbers for the rows and columns, and as a result you have odd numbers for the cells on both directions. Right. Now for the sizes, I would like to set the size for each edges of the squares to be 1 as for convenience later on, in order to do some calculations based on the sizes. So in order to do that, just simply copy this column parameter here and then paste it on the x, then do -1, which will be the actual cell number, so 49. So the cell number and the size is equal in this case. And do the same for the y, so copy this parameter rows and paste it to here, to the y size, and -1, do the expression -1. Now every grid cells have a size of 1 for each edges. Okay, now that's good. Let's go back, and also for convenience, at this point the center of this grid is placed on the 0, 0, 0 position, the origin. So I would like to move the edge of the grid to the 0, 0, 0 position, not the center, but the edge, so that I can do a calculation pretty easily based on the position of each primitive squares. So I'm just gonna use a transform and do some expression again. So for the y, I'll do minus $x_min to move it on the x direction, and for the z, I'll do minus $z min. Right. So now that the edge of the grid is placed on the 0, 0, 0 position, if I say that I want to get the grid squares, grid cells on position 1, 1, then I'll have this one, 3, 1 will be this one, and so on. So it's pretty convenient in this way. Right, now let's set some group for all those primitives, all those cells, which I'm gonna use it later on. And I'm gonna set the primitive group called open. Open means it's not used for anything right now. And this opened grid, open group, will be replaced with other groups later on, like such as rooms or walls and so on. Okay, now let's create some additional primitive groups based on some rules, based on some conditions of this grid cells. Okay, so in order to create some conditions, it's much easier to use a primitive wrangle. So I'm gonna place this primitive wrangles and name this prim attriv. And for the first roll, the edge of this shape grid should be wall, because you cannot access outside a dungeon, right? So this will be the edge of the dungeon. So for those edges, you always want to have a permanent wall. So let's set that as a group. And also, I might want to use the let's just set the edges as a wall. Okay. So the condition here. Okay. Well, in order to retrieve the edge of this primitive, you might also want to know the index for the x direction and y direction. So if I toggle on this primitive numbers here, it starts from 0 to some numbers here, going from left to right, go down one step, left to right, left to right, left to right, so on. And the left to right is the x direction, and going down is the z direction. So keep that in mind. I could create some index numbers for either x or z direction. So for the x index, I could calculate such as int x equals to a primitive num and modulo it by grid, number of grid on the x direction. And I don't have this parameter yet, so let's promote this to get it from outside, maybe retrieve from this grid parameter. So let's have this grid x. Maybe I'll just use as a float for convenience. So grid x chf x float grid y chf y. Now it's actually a z, but I'm just saying as a y since this is 2D. Okay, and promote this and go back to the grid. And let's copy some parameters. The one that I want to copy is those sizes. This is the actual size or actual number of the cells for x and y. So let's copy this first for the x and go back to the primitive wrangle and paste it here. Oh. Paste relative. And let's do the same for the y and just replace this x with y. Alright, let's check. Okay. So promote it. Now, the actual x index, I'm gonna name it x index, is going to be a actual primitive number, which is the number shown here, and modulo by this grid x number. And also y index is, in this case, it's a floor prim num divided by grid x. Okay, well, let's check this if it seems correct. So I'm gonna, for each primitive, I'm gonna assign this value as a attribute. Okay, and let's check by making some markers here if I really got the correct index for the x and y. So the attribute for x, I'm gonna name this x. Let's see. So for the x direction, it always starts from 0 on this side and going one step to another until 48. So that seems good for the x direction. Let's check the y as well. Let's make another markers. Let's change the colors to red. And y. Let's hide the x one. And this one goes from 0 to 1 on the z direction, and that seems correct. Okay, now that looks good. Now let's hide these markers and let's use those x and y indexes as a for a condition in order to check whether the primitive cells is on the edge of this grid shape. Okay, so that is pretty easy. If x index is equal to 0, or if x index is equal to grid x minus 1, or y index equals to 0, or y index is equal to grid y minus 1. Okay, and for those edges, I'm gonna set the primitive group as a block. So that you cannot use it for the rooms or paths. It's gonna be a wall, permanent wall. And let's set the open group to be 0, since it's no more cannot be used no more anymore. And also, in order to see it clearly that it is a blocked cell, let's change the color as well by changing this color to black. Okay, now the edge has been changed to a black. Maybe I should change the background to light so that I can see it clearly. Okay. Right, looks good. Now next thing, let's create some attributes that I'm gonna use later on in order to do some calculations using primitive wrangles or detail wrangles. So I'm gonna create a attribute create and create some initial attributes. Alright, the first thing I would like to create is called pick indexes. It's for the detail integer array, and I'm gonna use it in order to store some index to choose from. I'm gonna explain it later what it really does. And also a path count. So this will stands for the number of paths that you will have, number of paths. So for this will be the detail as well. And integer, since this is just a number and starts from 0, that's fine. Okay. Now let's create another one. And for this one, I'm gonna call it path ID. And it's gonna be for the primitive and integer and this will be a ID number for each cells. And if it's assigned as a path, if it's used for the path, then each path should have some IDs, like the type of the ID, type of the path. And initially it's gonna be -1 because we don't know if the initial cells will be path or not. So, and if it's more than 0, then it means that it is assigned as a path. Okay, let's make another one. This time it's a room count. As the name says, it's the number of rooms that you have currently. So detail, integers, and starts from 0. It's fine. Okay, and finally, room ID. Same for the path. It's the ID for each room. So it's gonna be primitive, integer, and starts from -1. So each cell will be either room or path or wall. And if it's wall, then both room ID and path ID will be -1. If it's room, then the room ID will be more than 0. If it's path, it's the room path ID will be more than 0. So that's gonna be the rule here. Okay, so I have created a necessary attributes here. Let's check. Going to the inspector's geometry spreadsheet, going to the primitive. I have X, Y, and room ID, path ID, which is initially -1. That's fine. And some are blocks. These are the edges, I believe. And other one will be open, which is those white cells. And for the detail, I have path count, picked indexes, and room count. Okay, that looks good. Now, the next thing that I would like to do is to create some random random rooms inside these cells. So let me explain the detail algorithm how I would do that in order to create a random number of rooms, random size of the rooms, to fill those empty spaces. Okay, so the algorithm that I'm gonna use to create a random size of rooms in specified area is like this. So first of all, you define the minimum and the maximum size of the room, and which I already did in a controller null node, and using that create some random size for the room and place it anywhere inside these empty open space, like this. So the X and Y is random between the value that we have set and at the random position. Now, we're going to do some recursive method in order to fill in this empty space with other rooms. So the next thing I would like to do is, after I have set one room, then do a feedback loop, then create another rooms in other empty spaces like here, and do continue it until there is no much space for the rooms to be created. And there are times that if you try to create a randomly chosen size of the rooms and into empty spaces, you might have this kind of duplicated or merged positions like this. And in that case, you will skip this iterations and do another one going back to the one before and do another iterations, picking a random positions and see if the rooms will be created on empty spaces. So it's like continuing doing like this, and if it fails, go back and do another iterations and so on. So this method, you have to, it could go endlessly, like infinitely, because in theory you will be able to fill in like every single cells with the rooms, but in reality it's pretty much impossible, because it's gonna take tons of time to actually to fill in every single cells like this. So at some point you have to stop it, and as a result you will have some empty spaces between a rooms. So you need to control the how many iterations you want to do for the feedback loops. If you increase the number of loops feedbacks, then you could have a lot number of rooms fill in the spaces, but there are some point that no rooms will be created even if you continue doing the feedback loop. So you gotta control this number of iterations for the loops at some point. So I'm gonna make it as a parameter so that you can control by yourself. And if the loop iteration is small, like 10, then the maximum number of rooms you could get is actually 10. If it's 100, actual maximum number of rooms that you could get is 100, but at some point it will stop or skip creating the rooms like this. So actually you could have much less number of rooms than the maximum set iterations numbers. So, but that's okay. So what I would like you to keep in mind that don't try to set like exaggerated number for the iterations for this one, like 1,000 or 10,000. I mean, it could still calculate it. It could still fill in the space with a lot of rooms, but it will just do some unnecessary calculations for each loop. I mean, this kind of skip will happens like so many times if you set the number of iterations too big. So maybe like 100 or 200 might be a good numbers for the size of 50 to 50 grid. Well, for that one, I mean, you could just try changing the parameters by yourself to see what's the balanced numbers here. Well, keep that in mind. This is the actual algorithm in order to create random rooms, and let's do that. Actually, do that using Houdini. Right. Let's go back. Now, since we're gonna do a feedback loop, I'm gonna use a for each loop in Houdini. I mean, I could also use solver, but in order to like create tons of variations, I think it's a good idea to use for each, because you don't want any animations in order to create procedural dungeons, right? Okay, so I'm gonna use the for each number here and change the merge each iterations to feedback each iterations for the for each end, and for each begin I'm gonna change it to fetch feedback, and let's connect this to a set attributes. Okay, and So this is the number that we want to be able to control, like how many iterations you want to do the feedback loop. More feedback you have, more rooms you could have, more chances you have for room. Okay, so in order to control that, let's make another parameter here so that we can control it after we have created the definitions. So let's name this integer, and let's name this max room iterations, maybe. Okay, max room iterations, and from 1 to I don't know, maybe 1,000. I mean, you could change that by yourself later on if it's not enough. Okay, now let's copy this parameter and paste it here. Paste relative reference, right? Okay. So now the basic setup has been done for the feedback loop. Let's create let's actually write some script or vex coding in order to create a random room inside this empty spaces. Okay, so I'm thinking I'm just gonna use a attribute wrangle and change it to the detail, which I thought it's one of the easiest way to do this. I mean, I guess there are ways to do it without using the coding, but I always think this is much easier, so let me do this way, please. Okay, so let's open up. Oops. Oh, save this. Let's open up. Okay, how do I open up this editor? Okay, I'm just gonna write inside here. Maybe I should change the keyboard. Doesn't matter. Okay, so first of all, I'm gonna import some parameters. First one, the size, the minimum size of the room. I'm gonna just call it min, and maximum size of the room, I'll call it max. And also the grid X size, also grid Y. And some random seed, I'll call it room seed. Because we're going to use some random value in order to define the size and positions. And also, since we're inside the loop feedback iterations, a feedback loop, we can also get the iterations value from this for each count. So I'm gonna get the iterations count using detail at the from the second input, named iterations. Okay, now let's promote these all parameters and let's link it with the controllers. So first, minimum size for the room. Let's paste it here. Let's also paste it here and change the name here to the max. Right, and for the grid X and grid Y, I think I should copy it from this grid, which have which I used expressions to convert it into a odd numbers. So copy this size X and paste it to the grid X, and paste it here as well, and just rename this X to Y. Let's check if the numbers has been promoted. Okay, looks good. And for the random seed, let's create a seed parameter as well inside this null controller using float, maybe from 0 to I don't know, any numbers, and I'll just call it seed. Apply, copy this parameter and paste relative reference to this room seed. Right, now let's start writing some code here. Okay, now first thing I'd like to do is to create some function in order to get the value between the specified minimum and the specified maximum value, get the random value between the minimum and maximum, because I'm gonna use it many times, both for the width and the depth, and maybe for the position as well. So since we're gonna reuse this same function, I'm gonna first create some function, and all those values have to be odd numbers, so I'm gonna call it randodd. And since this is gonna be a random value, I need a seed and the minimum value and the maximum value. And since all these gonna be used for the size or the position, it's always have to be an integer. The size stands for the number of cells on X direction and Y direction. The position could be counted from 0 to some index numbers for X and Y. Alright, so value, first of all, let's create a integer random value using fit rand, using the C numbers, which create a random value between 0 to 1 and map it to minimum and maximum using fit function, and change it to a integer by using rint, or maybe floor might be better. Maybe I'll int. Okay, and since this value could be odd or either odd or even numbers, and if it's even number, I want to convert it into a odd number, so I need some additional calculations using module like this, and finally return value. Okay, so this is the function that I want to use in order to create a random odd number between the minimum and maximum. Okay, so let's just use it right away. First of all, the size for the X direction for the room, so int sx size x. Use the function that I have just made and give some seed value, maybe all different for size x, size y, position x and position y, so multiply iterations with some constant random numbers that you have chosen by yourself, and plus random room seed that you have promoted from the null controller, this one, so that you can also control it later on using sliders by yourself. And in between room min and room max. Okay, sy, do the same, pretty much the same, so just copy this and just change this constant number to some other values. Anything is okay if the value is different. And let's also do the positions as well. So copy those two lines and name it. I'm gonna name the x1 to the xid, and I'm gonna name the second one, the y direction one, to be the yid. So this xid will be the initial position of the rooms on which will be the left top corner position, and then use those sizes to define the actual room cells. Okay, now for this one, the minimum maximum is gonna be in between 1 and grid x minus 1 minus s x. This one also grid y minus 1 minus s y. Okay, I'm missing one m here. Okay, so the reason this is because you want to start from this open value here, open group here. If you start from 0, then it means that you will also want to check the edge as well. But in this case, the edge is permanent wall, then you cannot use it for the room, so I'm just skipping it by setting the minimum as 1. And for the y, for the maximum, grade x minus 1, which means that you want to end up the value from until the end of the empty spaces, just skipping the end edge part for the x, and y as well for this one. And this minus sx and minus sy, which is the size of the room, is because you have already created the size for the room for the x direction and y direction. And so if you create like 3 by 3, if the number was 3 by 3, then the initial position cannot be somewhere like here because it's already going outside the edge or the basic shape. So to prevent that, I'm just setting some additional rule here that the initial index should be somewhere in between the first empty box and the end of the empty or open cells minus actual cell size or actual room size. Okay, now having those informations, let's try to create a room. I say try because it sometimes fails, as I explained in the sketch, that even though I have these conditions, rooms could be overlaying with other rooms, and that will be problematic. You have to skip it for these iterations. So I'll do the check for that later on. But initially, in order to create a room with those informations, I'm gonna write like this. So if I use the double loop, the nested loop, starting from xid minus 1 until xid plus xsx plus 1, and add I by 1, and do another loop here. Let's copy this, change I to n. Okay, and close the loop. Now the reason why I created minus 1 and plus 1 for the range of the loop, not just by starting from xid, is because after you created the room, you also want to round, or you also want to cover the room with the permanent wall. So these -1 and +1 will be the place where you want to set the permanent wall after you created the room. So that's why I added some additional 1 value here for the edges. Okay, room edges. Alright, now let's get some primitive numbers, just these one, by using the x value and y value. And in order to get the prim num, you can calculate it by grid x times n, grid x times n plus I. So this will be the actual primitive number which specify the position of the primitive or the cell. Okay. Now let's make some conditions if it's on the edge or if it's for the room. Okay, if I equals to xid minus 1, or if I equals to xid plus sx, or n equals to yid minus 1, or n equals to yid plus sx. Then in this case, this means that this is the edge of the room, which should be the wall, which should be permanent wall. So in this for the group, I'm gonna have to set the block group. So set prim group block prim id or prim num 1. And also if it's wall, then it's no more gonna be open. So for the open group, set it to 0. And also, since this is a block, in order to see it clearly, let's also set the color. So set prim attriv cd prim id to set 000. Right. Now else, if it's not the edge, which means it's gonna be a room itself, then let's set some group or attributes to use it for room. And this is the case where you want to also check if the cells that you are going to set it as a room is already used as a room previously. And if it is, then you want to skip these iterations and go for a next random iterations, random positions and random sizes. So let's do some checking function here. So if im prim group, if the cell is already open, if the cell is still open, then you can set it as room. So set prim group room prim id 1, set prim group open prim id to 0. Since this is no more open, this is already used for a room. And also let's set a set prim attribute called room id. So since we're gonna make a new room, I want to set this room an id, and the id will be the last number of well, it's gonna be incremented by 1, so I'm just gonna use the room count starting from 0. So initial number of room count will be 0, so the initial room ID will be 0 in this case. And set prim attribute, another attribute, in order to set the color for the rooms. I'm gonna set some random value here, so that we could see it clearly what if it's used for room or not. And I am going to set some random value here based on the room ID, because yeah, since in order to check that each room ID has different value, or each room has different ID. Okay, and I'm gonna use rand, and I'm gonna also use the iterations. Maybe just use the room ID. Maybe just iteration is fine, because each iterations you have different room IDs. So, and multiply it with some constant random numbers plus room seed. Did I have a room seed? Okay, yeah, I do. And that's for the red and rand iterations times some random constant numbers plus room seed again. And for the blue, I'll just set the 2 to make it bright blue. Okay, check if I have any errors. No, it seems good. Right, now next thing I would like to do is so I have checked if the cell is reserved for open, but if it is already used, if it's not open, it's already used for some kind of purpose, either room, maybe a block, maybe something other one, then you want to skip the whole iterations for this feedback loop. So I'm gonna create some flag here. Maybe I'll call it skip as an integer, and initially it's 0, but if you find anything that's overlaying the previous cells that's being used, then just change the skip flag to 1, then break the for loop. Now after breaking the for loop, what I want to do next is to first of all increment the room count by 1, and also apply the skip attribute to the detail attribute, and actually use this detail attribute skip in order to check whether we're gonna use this output from this room set attribute for the next loop. And I seem to have some errors here. Let's check what it is. Unexpected curly bracket 2858. Okay, somewhere around here. Okay, I was missing one more bracket here. Nope, not yet. Okay, I was writing prim ID. It should be prim num. Sorry for that. Okay, this one as well. Right, now that should be good, I think. the problem is I don't see any color changes, so I think something is still missing. Let me check. Let's also check the attributes here. Okay, it's already skipped for some reason. And okay, I did some stupid mistake here. First of all, this line, second for loop, I was writing xid here, so I have to change it to yid -1, and this one also yid, and this one also. This was written as sx before, so this is why sy. And other than that, these one, I think this one was also sx, so you have to set it as sy here. And all the other one looks okay, I think. And okay, so as a result, let's set this to iterations to 1 so that I can only see 1 iterations first. And if I change the random seed, okay, it seems like the position is on this crossing line, so I think I need to tweak some random seed here. Probably. Maybe I would like to. Where is it? Here, okay. Maybe I would like to multiply those values as well on room seed with some constant numbers, which is all different. Okay, this should see it. Okay, that looks much better. Now, so the initial room setup, initial room creation seems to work well, but if I increase the number of iterations, let's go back to the for each end, and if I increase this, and as you can see, there are points that the room is overlaying to each other, which is not what we want. We want to skip the loop when it's being duplicated on the same position or close position. So in order to avoid that, in order to avoid duplicated or overlaying stuff, we have to create some switch node in order to actually skip this code when we have this skip attributes on detail. So let's create a switch node. No, switch node. Switch. And also let's connect this room set with the null node named as room set. And first connect this room set to switch, and then connect this for each begin one to the second input for the switch. So the rule here is that if you find the detail attribute called skip being valued as 1, then the switch one will wanna use the initial value here come from the for each begin. But if the skip value is 0, then that means that there's no overlapping, so you can use this one instead of the first one, so you don't have to skip. So let's write that condition, but actually it's pretty easy. It's just checking the detail attribute, which is in the room set, call skip on the first value. So if it's 1, then it's gonna use this one. If it's skip, it's gonna use this one. If it's skip, if you don't have to skip, then it's gonna use this one. Then let's go back to the for each and let's increase these iterations to see if there's gonna be overlapping. And seems not. And looks good. Oh. Yeah, I don't like this Macintosh behavior. Okay, I have set it to minus. So, as you can see, if I increase at this point, it's pretty hard to have another room filling in the space because we don't have much room left. And it's gonna be kind of a luck. You need some luck to fill in all the spaces, all the left out spaces. So let's keep this something around 200. And after that, we just set the number of rooms as it is, and for the rest of the spaces, we're going to use it for the path. If I decrease this, the number of rooms will be decreased as well. So that's where you can control the number of rooms. Right, so that's good. It looks good for the rooms. Let's go to the next step in order to create a path to the leftover empty spaces. Now going back to the Bob Nystrom's article, in order to create a path in between the rooms that we have already created, such as these one, the way we want to create the path is like this. So we have these rooms, and what Bob Nystrom is suggesting is to use a maze algorithm to fill the leftover open spaces like this. And he said something about flood fill algorithm for the maze one. Doesn't really show the detail what kind of maze algorithm he's using, so I go back to this Wikipedia page for the maze generation algorithm, which I already did with the past tutorial using mazes on any geometrical surfaces. But in this case, it's gonna be much simpler because we're just gonna use the grid. So I'm gonna use the same algorithm that I used before, which is a recursive backtracker, or this one, the depth first search algorithm, in order to create a maze algorithm in this case. And I'm gonna use this algorithm in order to create mazes like this in between those empty black spaces, which in our case it's the open group. Okay, so let's do that. So now we have these rooms at this point. What we want to do now is create some initial settings in order to create a path. So let's do that. So let me just group these first. And let's do this. Okay, first of all, we'd like to set some initial attributes or groups for the path. So let's the way the position the cells that paths will be used is kind of a bit limited, because we are limiting the size of this grid, the whole grid, to a odd number for the x and y. So let me explain in the sketch. So this is kind of examples. The yellow is the wall, the block part. The red is the room that have already been used, and we want to use you want to create the path onto this empty places. Now, in order to do that, the first rule we want to preserve is to let the width of the path to be always one cell. So you don't want to have a path like this, which becomes like a room, but you always want to have a single width passes like this. And in this case, this part should be a wall afterwards. Now keep that in mind. The path, if that it is, then there are places that paths should never go. For example, in this case, these places, or these places, or these places. If the path comes at this point, then you have some problem here, because as you can see, I mean, you could still create a path like this, maybe like this, but as you can see, if you want to keep the width of the path to be single cell, then these empty spaces should be wall, but then the wall will have a double-sized layer, like here. This is also not pretty, and here as well. And these places as well, if you have passes like this, then these, and even if you places pass like this, you somehow have to fill in those places with the wall, which will create this kind of double-sized wall, which is not pretty. So, in order to prevent that, you could initially create those places where the path should not go to be a block as initial setup, so that the path could start from somewhere except for these places and could create a single width path without setting the leftover walls to be double-sized. So that's what we want to do. And the rule here, where those walls should be placed, there are some rules. If you look at it carefully, it is always on the odd number for the x direction and the y direction. So in this case, it's 1, 3, 5, 7, 9, 11. And for the y, it's 1, 3, 5, 7, 9. As you can see, anywhere that odd number crosses, there should be no path. So in this case, 9 and 3. this should be wall. In this case, 5 and 7, this should be wall. 3 or 7, this should be wall, and so on. And these places, other places, it's not crossed by any other odd numbers, so you can use these as a pass. So that's the initial rule what I want to set up. So let's do that. Okay, so I'm gonna create a primitive wrangle. And I will call this path block. And in order to check whether the cells on the x direction and the y direction is the odd number or not, I will retrieve some values which I already set it as a index for x and y here. So x, y. So int x equals to I at x, int y equal I at y. And also let's also check if the primitive is open or not, because I only want to make a block when the cell is still open. So in prim group 0 open prim num. Okay, so if is open, if the cell is still empty, then check whether the x value, the x index and the y index is odd number. In this case, it starts from 0, so you have to check if it's the even number, because it doesn't start from 1. If it starts from 1, then yeah, you can check for odd number, but if it starts from 0, then what you want to check is if it's on the even number. So x modulo by 2 equals to 0, and y modulo 2 equals to 0. Then set prim group open to be 0. It should not be open anymore, but instead it should be block. No path should come here, and to make it easy to see if it's being blocked, let's set the color as well as a black. Right, okay, so these are the places where you don't want to place the path. Okay, straightforward, easy to see, I guess. Okay, is this okay? Prim num, right. Okay, next. Let's, for next part, I want to set some cells used for start position for the path. So I want to search for the candidate's position in order to let path grow. And that is the best place to start the path are the diagonal places, diagonal position of the cell for those blocked single blocks. So that's gonna be either these places, this places, this places, these places. I don't want to start the path from these places in between the block, like here, like here, like here, because if you start from here, there is a chance that you might create a looped path. But by starting from the diagonal position of the block, you can kind of prevent creating a looped path by setting some conditions. But it's more easy to set a condition like that. So that's kind of my own strategy in order to create a feasible path. So let's do that. In order to do that, I'm gonna use another primitive wrangle. Name this start candidates. Maybe path start candidates. And check. So these are the position that I want to check. So it's pretty much the same with this one. It's just this time we want to check if the cells is on the even position. But in this case, I am going to check like this. I at x is equal to 1, and I at y modulo by 2 is equal to 1. Then let's set the color of the primitive to be something different that we be able to see that it's a candidate. Then set prim group, set it as start, and prim at prim num position. Also, let's also set this starting index, this primitive num, into a detail array named as a pick indexes. So we want to pick some random indexes out of this pick indexes array. So set detail attrib 0 pick indexes num append. Okay, and seems like I am also setting a starting candidate into a room as well, so that's not what I want, so only to the opened space. So let's filter this to the open group. Now that's good. So these green cells will be a candidate for the path to start from, and these green primitive indexes are stored inside a detail attribute like this. So these are the primitive numbers for each green cells, and we're gonna pick from one of these indexes to use it as a starting point. Alright, next we're gonna use a lot of polyneighbor functions later on, but polyneighbors is kind of a expensive function, so we're not gonna change the order of the primitive, so we're just gonna store all the neighbor indexes into each primitive so that we can use it later on many times. So another primitive wrangle. Let's name this set neighbors. And for each primitive, I am going to set a attribute called neighbors using poly neighbors. So each primitive will have an information like what primitive it is adhere to. attached to. Okay, let's check geometry spreadsheet and go into the primitive angle attribute, and there is this new attribute called neighbors, which gives you the information like if what number of primitives it is attached to the ID 0 or these. So maximum 4 neighbors, minimum 2 neighbors. So this one will be the first ID called 0, so it only has 2 neighbors, and that seems correct. Okay. And last setup, I need to have another attribute, so let's create an attribute create. And most of them, it's gonna be a detail attributes that we're gonna use for a path creation. So let's name this path attrib. And the first one, it's gonna be detail and named as restart in order to restart calculating the path. It's gonna be the flag, and could be integer, I think 0 or 1 in this case. Okay, and let's add another one, name it finish. This is to determine whether the calculation has finished or not, the path creation has finished or not. If it's finished, then you can leave the loop, since we're going to use another feedback loop for the path creation. So let's make it integer. So if it's 1, it's finished. It's 0, it's not yet finished. Okay, other one, let's create attribute called other. And this is gonna be a detail attribute again. And this is another flag if you need to create another path, another type of flag at the different places. So it's gonna be integer again, 0 or 1. Right, that looks good. So 3 detail attributes, all integers, and default. Maybe for the other, let's set the default value to 1. And for the other one, let's keep it 0. Alright. Now, since I told you I'm going to use the feedback loop in order to create a path into this filling empty places, opened grouped places. So let's create a feedback loop for each number. And for the iterations, it could be like really large numbers like 10,000 or 100,000. That is because we're gonna just stop calculating when the path fills all the spaces. So after that, after filling all the spaces, then you can just skip all the iterations by using this stop condition. So let's just keep it like 10,000 and set it to feedback each loop. Let's set it to fetch feedback as well. Okay. Now, since this is initial writing, let's keep it a bit smaller because we don't want to crash it by writing a wrong code. Okay. Alright, then let's start by creating a null node to just right after the feedback for each begin. I'm gonna name it start, and let's create a first vex wrangle. This time I am going to create a primitive wrangle. And this primitive wrangle will gonna be used for the path generation. Let's create it here. And connect the for each count to the second input like this, since we're going to use the iteration value here. So let's start writing some code. So we want to do start generating the path from the lastly created the end of the path. And for the end of the path, I am going to set a group called last path. So using this information, I'll be able to create a growth for the path in order to grow like a snake. And I haven't set last pass yet to previously, but I am going to do it later on. And it's gonna be used in the feedback loop later on, so it's not gonna be a problem if we don't have it initially. For initial loop with this script, it's gonna be skipped because at this point we don't have this last path anywhere. So. But keep in mind that this is going to be used for the path growth. So the first thing I need is the iterations value using getting from the detail. Okay, and also let's get the neighbors value for each primitive, which I have already stored it inside the neighbors attribute. And let's make the array call can goes. This is to determine where this next path could go, which cell could be used for the next path. And I'm gonna make it as an empty path, empty array, and let's make a loop for each neighbors. And get the neighbor value, neighbor index, which is gonna be the primitive numbers next to the last path. Okay, seems I got some errors. Okay, I'm missing the lengths of the neighbors. Okay. Now, say if this is the last path that we want to start growing from, then when you get neighbors, it's either this one or this one. Okay. Now the first thing I want to check is if it's the last pass, and if you get the neighbors this one and this one, you want to check if either one, each one is open space or not. If it's already used as a path, then you cannot go there because it's already being used as a path. Or if it's a block, you definitely cannot go. If it's empty, then there is a chance that this path could grow to that direction. So let's check by calling in prim group, open at this neighbor number, and also let's get the neighbor position. Pos prim 0 p, so that's gonna be a center of the primitive, and if is open, then there is a chance that the path could go at this direction. Now if it's open, then what I want to do is to check another neighbors. Let's say this is opened. This is the initial last path cells that we want to grow the path from. Then this is the neighbor which is empty or open. Now the next thing you want to check is whether this check the neighbor of this neighbors, the neighbor for this one. And for this one, you want to check the another neighbors for this one, for this cells, and see how many passes it is attached to, so that this check will be used, whether this neighbor could be used for the whether you can use this pass to go for the next pass. Because if this pass has like a lot of neighbors with already connected path, then there is a big chance that you're gonna create a looping path, which you don't want to have in this case. So that's why I'm going to check another neighbors. So int na2 and prim 0 neighbors at this neighbor position, and let's see how many path you have at this neighbors. Right, starting from 0. Now let's loop through all the neighbors for this one, starting from 0 and lengths neighbors to get the neighbor 2. And let's check if the selected cell, the neighbor cell, is either path or not. So in prim group path at neighbor 2. Now initially we still don't have this path group because we haven't set it anywhere, but we're gonna do it later. And since this is a feedback path, after the first iterations, some cells will have this path group. Okay, then pass count 1 or is path. Okay, now if there's only one path count, spell mistake, path count, then which means, so starting from here, and if the neighbors here is empty, then if you look at the neighbors of this cells, this one and this one, and if you only find one path, which initially this starting from here, this should be a path, already a path. So this path count should always be more than 1. And if it finds it just one path count, which means if it doesn't find this as a path, then it's a good to go place. If this neighbor is a path already, then there is a big chance that it is already connected as a path like this, maybe a snake path like this, and by making a path, by going to create this neighbors as a path, then there is a big chance that this is going to be a looped path, which we don't want to have as a maze. So to prevent that, we're gonna create a condition here. If path count is less than 2, which means is if it's equal to 1, then push can goes with this neighbor. So this neighbor can be used, is gonna be a candidate for the place to go for the next step. Alright, now let's leave all the for loop, and by then the end of the loop, that you will have a number of indexes inside this can goes array, which is the place you can go next. So let's check how many numbers you have inside this can goes, and if it's more than 1, if it's more than 0, then you have a chance that you can go on this one of the index inside this can goes. So make a condition like this. If the length of the can goes is more than 0, then let's pick one of the index from this array, maybe using some random value. So let's create some random index using floor rand, maybe based on the position of the primitive. So add p times some constant value plus maybe create some seed value as well, multiply with some another constant value plus iterations times another constant value. Right, and this random value is going to be in between 0 to 1, so let's multiply it with the length of can goes. Then finally use floor to create index for the random index in order to get the item from this can goes array. And finally the index, that the primitive number that we can use to go for, can be retrieved like this. Alright. Okay, now for this primitive number, maybe if I was looking at this neighbors, then set prim group path can go to 1, so set it as a path, and set prim group 0 last path can go to 1 as well, and set prim group open to be disabled for this one because already used as a path. And let's also set the color for this one. Set prim group, no attribute. Set prim attrib 0 CD. Same as the current primitive color. Alright, now also let's get the path count, how many paths you have currently from the detail. Path count, and use it to set it as a path ID. So set prim attrib path ID can go with path count. Same as a room ID. Okay. Also for the mazes, I am going to use I'm gonna have a stack where I wanna use it to go back later on in order to create another branches, which I explained on the maze creation tutorial, so maybe you can watch that if you want to know the detail about creating a maze. So set detail attrib 0 stack. This is where I want to store all the primitive numbers which have already been visited. Okay, now more to go. Now retrieve some pick indexes from the detail as an index. And if in prim group 0 start for can go, then the can goal index is already being used as a path, so this is not going to be used as a starting point or candidate, these green things anymore. So let's remove that from the group. Set prim group 0 start can go 0. Also pick indexes had the list of start candidates numbers, primitive numbers, so you also want to remove those numbers from this pick indexes. So remove value indexes can go. Right, then update the pick indexes using set detail attribute, just replacing the array. Like this. Okay. Now, if there is no can goes, so if the number of can goes, the array is 0, which means there's no way to go. There's no place that the last path could go to. Then you want to restart creating another path. So set detail attribute restart to 1. So set the flag to 1. And finally remove the last path attribute from the current primitive, this one. So set prim group 0 last path prim 0. Alright, and I have some errors here. Okay, where could that be? Invalid group, last path, syntax error 48. 48, this one. Okay, I'm missing a comma here. Nope, still not. Okay. Indexes. Okay. Spell mistake. Right. Looks good. Though currently I don't see any updates because initially it doesn't do anything, as I say it, because there's no last path yet. So you have to create last path at some point, and I'm gonna have to do that. And before doing that, I am going to create another vex in order to do a restart calculations. So as I set it here, if there's no way to go, if there's no direction that you can go like this, then you want to restart from somewhere else. And in order to choose where to restart from, I am going to use this stack information. So let me explain with the sketch a little bit. So say you have those cells creating this kind of maze. And coming here, there's no other place that it can go. Then you gotta go back. I mean, if there's no neighbors that you can go for, this way no, this way no, this way no, then go back one step to this one, which is listed in the stack, and try to look for the other places. And if you find empty, then you can continue going. Though this one makes a double loop, double like sized path, so you cannot go this way, but maybe you can go this way. And if it's also blocked at this point, then go back again, and maybe starting from this one, but maybe these are all blocked out. Then you have to go back one more. This is also blocked, then go back one more. Then from here, maybe you can go to the right side or upper side. Maybe choose this one. And so on. So for the stack array, you store all the visited cells indexes. So starting from here, you put this in the stack, this one also in the stack, this one also in the stack, this one also in the stack. And after you have been blocked by the walls, then go back to see the stacks and check each indexes whether you can go to the other direction. So that is how the stack is used, and this is where I am going to use this stack. So I am going to use an attribute wrangle, and name this as restart from stack. Right. And let's set it as a detail attribute. Okay, now the first condition, if I restart is equal to 1, then do a restarting. Now get the stack from the detail attribute, go stack, and also get the temporal stacks by slicing or copying the stacks. And let's create a flag called last path created. And do the for loop through the stack. Maybe starting from the end of the stack, because you want to go back from the lastly created stack index. So for int ei equal to the length of the stacks -1 until 0, and -1 for each loop. And if last path created equal to 0, which means the last path is not yet created, then get the stack and stack from the stacks array. And for that one, get the neighbors by getting the primitive attribute neighbors, which we have already stored for each primitive, and do another loop for each neighbors, and get the neighbor primitive in numbers, and check if the neighbor is open or not. So it means whether the cells can be used for the path or not. So if int is open, imprim group open neighbor, and if is open equal to 1, then get another primitive just like we did before, in order to check if it's gonna be if there's gonna be a chance to make a looped path, which we don't want. So prim 0 neighbors. Now this is a lot of coding here, you know. And set path count. If its path count is less than 2 or equal to 1, then that's good to go. Okay, and the path count, in order to count the path count, I need to do another loop. So this is like a triple loop. Length neighbors 2 T, and neighbors 2 equals to neighbors 2 T. Oops. Alright, and check if it is path or not using imprim group path neighbor 2. Okay, and add this path count using this is path. If it's path, then the path count will be added by 1. Okay, and lastly, check if the path count is less than 2, means equal to 1, which means you can go to that place for the next path position cells. Okay, in this case, set prim group path neighbors 1 and set prim group last path as also 1. Get the color from the stack, which is the starting point of the restarting path. And set prim attriv cd neighbor color. And also set prim attriv pass ID from the pass count from the detail attribute. And set prim group open to 0 because it's already being reserved for the path. And lastly, last path created, set the last path created flag to 1 because the path has been created. And finally, set the restart to 0 because you don't need to restart anymore, and leave the loop. Okay, it's a lot of code. And else, if you see more than 2 for the path count, then set prim group 0 open to 0 still. You don't want to set it as a path, but what you want to set it as is a block. So it's a permanent wall. So in order to prevent being a looped path. And set prim attriv cd. Since this is a block, set it as a black color for ease to understand. Okay, seem to have some errors here. Where is it? This one. Okay, I was missing S here. Okay, no errors, but still it's hard to debug because there's no visual differences here yet, because we still don't have a last path created for the initial values. So this is where we want to do that. Let's create a null node connected. Wait, before doing that, I think I need to write some more code here. So after leaving this for loop, so for checking all the neighbors, check if the last path created is equal to 0. Then if it's 0, then remove the index from the temp stacks. So this one, so remove this. Remove the index from the stack. Okay. And finally, still inside this restart, update the stack of the detail attribute to the temp stack. Well, the unnecessary stack being trimmed. Stacks. Okay. Okay, I hope this works. I'm not sure yet. Now connect the null node to the restart from stack, then name it other. And so this is where we want to set the last path group, which is going to be the initial position to start the path from. So we just want to have one cells to be set it as a last pass, so I'm gonna just use the attribute wrangle and set it as a detail wrangle. Attribute wrangle and set it as detail. Connect it with the other and path, set it as path start. Path start. Okay. Now let's get the condition using other, which I've created as a detail attribute, and if other is equal to 1, then if the length of the pick indexes is also more than 0, which means there are indexes left, which is those green cells. So if the green cells is still out there to choose from, then try to choose one from them. So index int indexes as an array is pick indexes. Get one index out from this pick index randomly. So I'm just gonna use another random value here, another seed. Maybe use an iteration again. So int iterations, a detail, second input, iteration, and iteration times some constant random value plus seed times some constant value. Right, and times length of indexes, and use floor to make it as an integer. And I think I do have some errors still. Where is it? 419. 1, 2, 3, 4. Okay, am I missing something here? Okay, I'm missing at mark. Right. And now now that I got the random index here, get the primitive number from the indexes. There's an index and set prim group and set it as a initial path. Also set it as a last path, which is gonna be used to grow the path. And also set the color so that we can see which one is the path. And since we're gonna have several types or several number of paths, so we want to change the path color based on the ID, I guess. So let's use path count as a seed. So set maybe red as a 2, so gonna be bright reddish color, and rand based on the I path count times some constant value plus seed value. Let's copy this one, change some constant value here. Yeah, and close the bracket 2 times. Prim. No, I think this is fine. Nope. It's not group, but it's attribute. Okay, still missing something. Okay, prim here. Alright. I think it's good. Do I see any changes? Nope. But let's write all the code first. Set prim group. So if it's passed, then it's not open anymore. So set it to 0. And also it's not a start anymore. So start to be 0 as well. And also let's create a new group called init. Set it as 1. And also set some primitive attribute for path ID. From the path count detail attribute. And another set attribute, but this time not for the primitive, but for the detail. For the stack. To append this visited primitive. So since if it's gonna be path, then it's gonna be used as it might gonna be used later on for another branch. Alright. Okay, now remove the index from indexes array and update the picked indexes or pick indexes with indexes, and also set the restart to 0, because at this moment you don't need to restart, and also set the other to 0. Right, and else, which was the condition for if the pick indexes is larger than 0, which means there's more than one starting point. But if there are 0 starting point, then it means that the creating path is finished. So set the detail attribute finish to be 1. Okay, it's a lot of code. I don't think a lot of people would make until here. Alright, now let's create a switch node to check whether attribute other is 0 or not. So switch connect those two, and if the detail other, the detail attribute called other is 1, then it's gonna be used. If other is 0, then it's gonna be used. And let's connect with this loop. Now set it to something like 5 to check. And if nothing happens, then something must be wrong, and let's check. Let's start by setting to 1 and check here if any last path is created, and it is created somehow. Yeah, and the color is set it, but I am not sure if I'm seeing it here. Maybe go to the object and go back to, and now I see it. Yeah, sometimes it happens. Maybe it's a bug with the Houdini 18, not sure. Now let's increase the iterations, and yeah, it seems to grow fine. Now increase this. I want to increase to some large numbers, but if I do that, right now there's no like stop conditions here, so it's gonna calculate all the iterations, which gonna be too heavy for sure. So let's create a stop condition if this by checking the finish attribute for detail. The detail attribute called finish, and if the finish attribute is 1, then just stop this loop. Okay, so here just gonna call detail, and the node that I want to check is this one, start. Start. So before starting the loop, check the finish value, and if it's 1, then just stop it. That's what it's saying. So let's try with 200. Still there's a place left to go for 300, and nothing happens, so something must be wrong. I think I missed setting other, the attribute called other at some point. I think I'm missing it somewhere. So let's, I guess I need to add that somewhere. Let me check where that is. Let me just pause this a little bit. Okay, I think it should be this one, restart from stack. I think I'm missing some code here. So after I have updated the stack, I think I need to set the detail attribute if the last path is not created, which means you have to skip to the other branch. So currently this area has been created as a path, but then there's no other place to go for this one, so you have to skip to other island like these or these or these or this. So in order to do that, if I have to check if the last path has been created, and if it's 0, then you gotta skip to the other island, and by doing that set the other to 1. Other means other island, and I restart to 0, because restart means restart from the other branch, and going to the other island is not like that, so it's a bit different conditions. And also I path count, add iPath count by 1, so because you're going to the other island, so the ID will be different. ID should be different from the first island. Now let's check with the... okay, now that looks good. Okay, let's... yeah, looking good, isn't it? So by increasing the iterations, it just fills all the empty island with the path using maze algorithm. Right, and even if I increase it to like 10,000 or 100,000, just stop when all the path has been created, when all the empty spaces has been used as for the path, and no unnecessary iterations will be used because of this stop conditions. Okay, yeah, that looks good. So this is for the path mazes. Now there are a lot more to go, because next we have to create a connections between rooms or between room and the path. Now let's do that. I'm gonna apply a network box here, and let's go for the next step. Now next thing we wanna do is to connect those closed rooms and paths together to create, so that you can access to all the rooms, all the rooms visible from anywhere else, using path and the rooms, by connecting path and rooms. The rule here, the algorithm here that we're gonna use here is called spanning tree algorithm, and it works like this. So first pick random room, single one random room, like the red one, this one, and then from this red room, look for the wall which could be replaced as a path or the entrance door. So the possible wall place that could be used is these blue lined, and the entrance door could be placed anywhere on this blue wall. Maybe placed here, maybe somewhere here, maybe here or here. That's anywhere is possible. You just roll the dice, randomly pick a place to connect with the next door path or room. let's say you have picked this place as an entrance, which connects this room with this path here. By connecting those room and paths, what we want to do is to convert this path as one of a same type with the connected room. So make this whole connected geometry or connected path plus room be one big room. And this will be the entrance door. Now, after doing it, pick for the next iterations, pick another room randomly, like maybe this time this blue one on the right bottom side. Then search for the connections. In this case, the left side wall and the top side wall could be used to connect. Is gonna be a candidate to be connected with the next room. In this case, there's only path available to this neighbors. So say if you have created a connection here at this cross, then making this in as entrance, the path connected to this blue room will be part of this blue room, will be swapped as a part of the room. And becomes one big room again. Now do the same thing for the other one as well, like maybe next time you get this green, and by rolling the dice, maybe this place which connects with other room will be the connection, and then in that case this red will be part of this green room. And continue doing it until you have one single big room, like this all color be one single color. And then you will be, and you will have all the rooms be connected together. You can access any other room, any rooms from anywhere else, and without making unnecessary loop route. So that's the basic algorithm for the spanning tree. Let's do that using Houdini. Now for this one, I am going to do another feedback loop again, since after connecting one connection, after creating one connection, then you have to go to the next loop, preserving the previous result. So you have to use the recursive loop, which is in this case a feedback loop. So create another for each number again, and let's do some looping again. Now before getting into the loop, I think I need to set up some attributes again in order to create a connections. So let me create a attribute wrangle and name it as room IDs to store all the room IDs. So let's let's start by retrieving the room count attribute from the detail room count and path count as well. Now let's check the detail. Now you have this path count. Oh, what's this path count? Okay, I think I did some spell mistake somewhere. Let's check. Search for the path. Not this one. Okay, this one. Have to set it to path count. Okay, any other one? Any other one? Nope. Okay, let's go back and check the detail again. So I have path count and the room count. So this means that I have 5 island of path. So this 1, 2, 3, 4, 5 looks correct, and I have 21 rooms. Okay, it should be 21 rooms here, 21 squares. Now that's what I am retrieving here, and create an array called room IDs. And using the room count, I am going to create an index, array of index starting from 0, and store it inside the array and use it later on in order to swap the room when combining the room with other room or path. So push room IDs with I and store that to a detail called room IDs. Okay. Now, if I look at the detail, there are some unnecessary attributes that we're not going to use anymore. So let me just delete those first before I get it into the connection. So I am going to use attribute delete. And most of them that I want to delete are inside the detail. So go into the detail, and everything I don't need, it's finished. Only used for the path creation. I also need other as well. I don't need restart as well. And I also don't need skip. And I also don't need stack. So which it created much cleaner. Yeah, it's much cleaner to see. Now that's good. I'll go back to the Wrangle. And let's continue writing some code. Okay, so I have set a room IDs. Let's check. Okay. Okay, I don't see it. Room ID. Okay, I have to set it to detail. Right, let's see again. Okay, so there are total number of 20 room. There are 21 rooms, and each rooms with the index number being listed here. So that's for the room, and I do the same for the path. So int path IDs. Create an empty array first. For int path count. push path IDs with the I and update the path IDs with the one I created right now. Check. Okay, so I have 0 to 4, 5 values for path IDs. Okay, that looks good. So let's get it inside the loop in order to create a connection one by one. Now, to make it understandable, to make it easy to see, I just gonna start with one loop and I have to change it to a feedback. So change this merge to a feedback each iterations, and then also for the for each began, change it to the fetch feedback. Now I'm gonna connect with the null node first. Name this connection. And let's create some primitive wrangle first. Primitive wrangle. And what I'm going to do is since the connection will be made on top of the block cells in this case, so that will be the entrance. So maybe it could be somewhere around here, could be around here, could be around here, so on. So, but the entrance cannot be on some places, some block places like here, which is the crossed position. Because even if you make the entrance here, you cannot access from this room to anywhere. So you have to skip some of the blocks for the candidates. And you also want to avoid these places, because even if you create a door here, when you open it, then you just go to the same room or same path. So that's also not preferable. So you also want to skip that part as well. So keep that in mind. Let's first create some candidates position where you want to use it, where it could be used for the entrance door, entrance place or connection node or cell. Okay, so first of all, run over the block is necessary, and also let's get some neighbors from the primitive attribute. Okay, and let's also get some initial value called room count and path count, which is going to be updated later on. And also room IDs, empty array as an empty array, and path IDs as an empty array. Right, and we'll go through the loop for each neighbors. Go through each neighbors with using loop and get the neighbor's value. And check if the neighbor is either room or path. So if it's room, use is room using imprim group. If it's room, and if it's path, use is path in prim group. At neighbor position in neighbor cells. So the neighbor of block should be either path or a room if it's connectable. If it's this one, then there might be only one room. So, but if the neighbor has two rooms connected, two rooms as a neighbors, or one room with one path, then you can use it for the connection. If you only have one room or one path for the neighbors, then you cannot use it for the entrance or the connection. And even if you have two rooms or two paths for the neighbors, if the path ID or the room ID is the same on the neighbors, different neighbors, then that's also not good. You just have to avoid it. So that's gonna be a rule that we want to use, we want to create, and there is an error here. Let's check what it is. 8 here. Okay, I am missing a bracket here. Alright. Now, next, let's add the room count with this is room condition, and also path count with this is path. And if is room, so if the neighbor is room, then let's get the room ID, int room ID prim 0 room ID at neighbor position. And if let's find this room inside this room IDs, and if you find it, then just reset the number of the counting of room count, because it's being duplicated, which is this case. Else push room IDs with room ID. Alright, and do pretty much the same thing for the path. Just copy this, paste it, and for the path, if is path, then the path ID is primitive path ID neighbors. And in this case, I mean, they're not gonna be duplicated path, because you always wanna look from the room. You're always gonna look from the room and not from the path. So I'm gonna skip this condition and just push path IDs to path ID. Okay, spell mistake. Okay, am I missing? Okay, path ID here, right? Okay, now here comes the condition. If room count is equal to 2, then that's good to go. Or if room count is equal to 1 and path count is equal to 1, then that's also good to go. So it's a pair of path and the room, or a room with the other room. So that's the pair that we can use to connect. In that, when that condition met, then set prim attriv. First, just change the color of the primitive to see where it is, where is the connection, and set it as blue color, really bright blue color, and set prim group, set prim group for connect candidate, prim num room IDs, and also set prim group if it's path connection, then connect path IDs. Wait, I don't need and here. Connect. Wait. Connect candidate primitive. Okay, so candidate should be just one, and for connect path IDs and connect room IDs, it's set prim attrib, not the group. So connect room IDs at prim num should be room IDs. So store all the neighbor room IDs and set prim attrib connect path IDs with the connected path IDs like this. Right, okay. Let's check. Where's the error? 31, 31, 31, this one. Okay, color, prim num, set prim attribute. Okay, I'm missing one bracket here. Alright. Now, so those green cells is the position which can be used, could be used for the connection. And other black one, the one that remains black, cannot be used for the connection. As I said, these cannot be used. These one also can be used because it's not connected with other rooms or path. So looks like those condition works pretty well here. Let's continue. I'm gonna name this connect candidate. Alright. And let's create another attribute, and this time what I want to do is to pick one of the room from here and actually use it to create a connection with the neighbor's path or room, other room. Alright, so attribute wrangle, connect it with this one, and also let's connect with second input with the for each count in order to use the iteration value. Right, and I'm gonna retrieve some random room IDs, so I'm gonna name this random room ID. Alright, and set it as detail. Okay, so in order to use the random, I'm gonna first get the iteration value. So in each root loop iterations, I have different value. Like this. And also let's retrieve the room IDs from the detail attribute. So this room IDs contains all the ID numbers for each room. So initially it's from 0 to 20 because I have 21 rooms. And now we come to the place where we choose one of the index from the array using random. So we use this kind of stuff before, floor, random, and then chf c value times lengths room IDs, and I think I need one more. Maybe add with the iterations times some constant value. Okay, do I need one more bracket? Maybe yes. Let's check. Nope. Okay, I shouldn't have. Wait a minute. This one shouldn't come here, but maybe I'll multiply this with another constant value, and this one multiply by length. Then finally use floor. Alright, that looks good, I think. Okay, now so this is gonna be the random index for the room IDs, and in order to actually pick the room ID, I am going to pick ID from this room IDs, and like this, and let's apply this to a detail attribute called pick room ID, like this, and let's check if I got a value. Alright, I do seem to have some value here. Okay, that looks good. And I have noticed that I have this seed value here, but I guess I want to link this with this initial seed value, so let's do that. And I think I do have another seed value from other vex before, so let's also do that as well. Let's also link that with the seed value. Do I have this one? Yes. Paste it. And I mean, if you want to have more control over the seed for each iteration, each like steps, then you can just have multiple seed value, but it's up to you. For this one, I don't have it. For this one, I should have it. Yeah. Paste it. As you can see, by changing the seed, path has just been changed, and that's also cool. And this one, nope. This one, I already did it. This one, no. This one, no. This one, no. Maybe that's it. Right, let's go back. And now I have set a pick one of the room. And now it's 18. Let's create another wrangle to do another setup that we need. Okay, my mouse is not working right now. Let me pause it. Okay, now it works. Next thing I would like to do is another setup. This time I am going to create a primitive wrangle. And connect with this one. And I'm gonna name this pick indexes Update. So before I had this pick indexes used for other usage, but I am going to reuse this for different purposes. In this case, to store the picked room IDs. Right. So go back here, go back to the primitive wrangle. And first of all, I'm only gonna look through the connected candidate. Not sure I'm spelling right. Connected candidates. So these green stuff that I'm going to look at. Filter. Then get the pick room ID from detail. Pick room ID. And if pick room ID is inside the connect room IDs, so each candidates, each green cells have this neighbor values for either path or room, or path or room with other rooms or so. And this time only look for the room neighbors. So in this case just run room, in this case 2 rooms. And from these connected room IDs, look for the pick room ID, which is the one we use detail wrangle to choose. And if you find it, then set detail attrib del pick indexes prim num append. Now let's check at the detail wrangle and pick room indexes none. Is that correct? Not sure if this is correct. Pick indexes. Am I spelling correctly? Pick room. Let's check. Pick room ID. Wait. Think I didn't change it to detail. Yeah, that's the reason. No. Being primitive is okay. I was just looking at the details, so my bad. Going to the primitive. And wait. Yeah, I think it's still okay writing like this. But I don't seem to find any updates for this pick indexes. Let's connect this and see if I still don't see it. Not sure if this is correct. Maybe it's okay. Yeah, I guess it's okay. Let's just continue and see if this still works. Maybe it's since this is a feedback loop, I think I needed to update it later. Alright. Now the next thing I would like to do here is to actually pick the connection point out from the room we have picked. So, but in that case, I guess I do need to have a indexes listed here, big indexes, I guess. So let's check what is wrong here. So for each primitive, I am getting the pick room ID, if I have it. Pick room ID, yes, 18, I do have it. And I am checking all the connect room IDs. Let's check for the primitive. Connect room. Okay, that's the problem, because it's all empty. It's not all empty, but yeah, I do have some value here. And there are some value 18, so that should be good. Now the thing is this set it as connect candidate? Okay, yeah, it does. So it should be okay. Okay, let's check. Connect room. Always a spell mistake here. Alright, now we have something. Yes, this is what I wanted. So these are the indexes of the candidate, the green cells, which we have picked the room, which is attached to the room we have picked. So if we have picked this room randomly, then these indexes are the primitive number of these green cells attached to this room. Right. Okay. Good to know. Now let's create another wrangle. This time attribute wrangle, and again set it to a detail. And let's name this pick connector. And connect the second input with the count for each count again to get the iterations value, as always. Now, first of all, let's get the pick indexes as indexes array. Indexes and I pick indexes, and also get the iterations. Because we're gonna use another random, and if the indexes, the length of the index is more than 0, which means if there's R candidate left, in order to use it for the connection, then pick one index from this indexes randomly. Again, use some random value. Rand chf.seed. Let's import that later. And plus iteration times some value here, some constant value here. Maybe I multiply this down as well. And multiply this rand value times length of indexes. And finally floor it to make it an integer. Okay, and so the primitive number of those green cells, it's gonna be prim num. get it as a prim num. Right, and by getting it, what we want to do next is to set the group of this connection cell. First, pick connector as 1, then set prim attriv. Let's set the color as well to prim maybe bright color, a bright red. And set prim group. Also set it as entrance. Okay, I didn't need this at mark. Alright. And it seems like this one. So this is the connection. So the picked room could be either this one or this one, I guess. And let's also get the room IDs, connected room IDs from this primitive. Connect room IDs. As well as the path. Pass prim 0 connect path IDs prim num, and update the picked room with rooms. So the detail attribute called picked room will be updated with the connected room IDs, which is retrieved from this red cell. So which means we have this room IDs and this room ID stored in the detail as picked rooms. And do the same for the path. I mean, this one is not connected to the path, but it could be like if the red cell is placed here, then you have path and rooms. So in that case, you also need this one. I add picked path equal path, and then ei bracket out pick indexes equal array, so empty to pick indexes. Right. Now visually I don't think there's much difference here at this moment. I have just picked this one, and in the detail attribute I have this picked rooms and picked path, and as you can see it's not connected to the path, so the picked path is empty, but the picked rooms, I do have 2 rooms ID listed, so this either one could be 18, the other one could be 19. Alright. Now, next thing I would like to do is to retrieve or retrieve the picked room as a isolated cells. So in order to path out the attributes to the other room, other connected room, so if the picked room is this one, then just retrieve this one and use that as an information to convert this one the same color and the same ID as this one. So in order to do that, let's just use delete freeze, And for group, I am going to create some condition here. So if room ID is equal to detail, and maybe I'm just gonna look at self, OP input, named pick room ID, and just delete non-selected. And I have select this room cell has been retrieved, so I guess the randomly picked room was this one, right? And the one that's connected to this room is, by looking at this red dot, is this one. So what I want to do is to change the attributes of this connected room cells, same as this one. So copy the attributes from here to here. That's what I want to do, including colors. Okay, so I am going to use a primitive wrangle in order to swap the color or the IDs or attributes for this one with this one, and connect this delete to the second input as a guide. And I am name this swap room. Okay. And let's filter some group, what kind of stuff I want to change. So one thing, this could be room or either path. So this could be a path or a room. And also it could also be an entrance, this red one. So also choose entrance. Right. Now write some code here. First of all, let's retrieve a picked passes. Picked path from detail. Picked path. In this case, it should be empty though. Still. Picked another one. Picked rooms from detail. Always be careful with the typos. I always do that. And also int pick room ID. Picked room ID, which is also stored inside a detail. Pick room ID. Picked path, picked rooms, pick room ID. Let's check. Pick paths, pick rooms, pick room ID. I think it's correct, right? And get the color information from the second input first, and all the colors on each primitive is the same, so I'm just gonna pick this first primitive color like this from the second input, and also retrieve the room ID from the second input. Again, every cell from the second input has same room ID, so I'm just gonna pick from the first one by setting it to 0. And I'm gonna check if this one is path or not, or a room or connector, I mean entrance. So is path in prim group path prim num, and if is room, then check using imprim group room prim num. Also check if is picked connector, which also means entrance in prim group picked connector. Seem to have like picked connector and entrance be the same meaning. I guess I don't need one of the stuff. This one seems the same, so just gonna comment this out, and I am going to just check the entrance is entrance. I hope this works. Okay, and by retrieving all those three conditions, let's do y one by one. If is path, then look through all the picked paths. This one, so for int lengths of the picked path, get the picked path. And if the path ID of this primitive, path ID of this primitive is equal to picked path, then what I want to do is change the color of this path to this referenced color, and set prim group path to 0, since this is no more a path, but it's one of the connected room. So path ID is -1, meaning there's no path ID anymore, and set prim group, swap it to room, and set the room ID with the retrieved ID from this delete, or this one, referenced one. Now that is for if this one is the path. I mean, this is obviously a room, but I'm just saying if this is a path, then just change that path to the room, and then change the color of that path to the same one, the same referenced one. Okay, now that's for the path, and do the pretty much the same stuff for the room. So if is room, so if the primitive is room, then for int AI for 2 lengths of picked rooms, picked room equals to picked rooms. If I at room ID is equal to picked room, then change the color of the room to the same as the reference one, delete one, and I at mark room ID equal room ID. Okay. Now did you see the changes? Let me disable this one and see. This is a bit darker blue, but by changing this one, it has become the same color, so it has been copied. The attribute has been copied from here to here, because this is a room connected. Okay, now if this is a entrance, is entrance. Do I have this is entrance? Yes. Okay. So I guess it's this red one. If this is entrance, then also change the color to the referenced color, which is this blue, and also change the room ID of this cell to room ID. And I also want, so since this was previously a block, so I don't want to make it as a block anymore, but make it as part of the room. So in order to do that, set prim group room prim num to 1, but instead prim group block prim num to be 0, and finally set prim group 0 entrance. Maybe I don't need to change this one. Let's keep this as an entrance because maybe I can use this group later on. Now, looks fine. Seem to work well. Okay. Now, I think the room swap seem to work okay. Now the next thing I would like to do is to do some remove some unnecessary stuff from the detail attribute. So in order to reset to continue doing the feedback loop. So attribute wrangle, and I'm gonna name this reset room IDs. Okay, I'm getting tired. Set it as detail. Right, and first thing, let's retrieve some values from the detail. So first thing, room IDs. Path IDs. And picked rooms. And also picked paths. And finally int pick room ID. Alright, now let's go through all the picked rooms using loop. And picked room equals to picked rooms. And if picked room is not equal to picked room ID, pick room ID, then remove the value from the room IDs. So that we're gonna delete the value from room IDs to reference from, because we have already combined those two. We don't need to have this ID which has been changed to this one anymore, so we have to remove the room ID like this. Now same for the path. If this was the path, then we also have to remove that from the path IDs. So but after I have removed the room IDs, I also have to update the attribute detail attributes by room IDs equal to room IDs. Okay, now copy paste these stuff that I wrote here and change it for the path. So picked path, and with for this one I don't think I need the conditions, because if the path was picked, then path will always be changed with the room for the room. Because if I look at this room, and if this was the connector, and if the other side was the path, then the picked path will always have to change to the room corresponds to this one. So I don't need conditions, it always will change. So we just remove value from the path IDs, use with picked path. Straightforward. And update the path IDs with path IDs. Update it here. Okay, and that should be good. Let's check. So if the room ID is here, the path ID is here, and for this one I think 18 or 19 has been deleted from this room IDs, and let's check if it has been. Yeah, 19 has been deleted, so that it looks good. Now at this end of the loop, let's delete some attributes we don't need for the next calculations. So use attribute delete, and for the delete detail attributes, I'm gonna delete picked path this, because it's gonna be updated again here using this one or this one. And same for the picked rooms, and also pick room ID, which will also be calculated on the next, newly calculated on next loop iterations. Where is it? Pick room, okay, this one. Alright, now let's check the detail attributes. It's much cleaner. Okay, now last of all, let's also reset those candidates, the green one, to a block again, just a normal block, because it's gonna be recalculated here again. So primitive wrangle, reset connect candidate, and go to the filter group, will be a connect candidate, and just set the color to a normal block color, which is black, and set prim group connect candidate B0. Alright, reset it. And I do seem to have some problem here because also the connection has been set it as black. So I think I need to set some conditions here for the swap room. So if is entrance, then set prim group 0 connect, what was the name? I'll just copy this one, connect candidate, connect candidate at prim num B0, so that it will be out of the connect candidate group. And looks good. Yeah, I do have this opening. And finally, let's also check if there's any room IDs or pass IDs left out in here in the detail attributes. If there's no values left for both path IDs and room IDs, then it means there's no more connection you need to create. So that means you can just finish the loop. So let's make that condition using another attribute, wrangle, change it to the detail wrangle. Let's call it finish connecting detail, and if so in the end the number of rooms should be just 1 and the number of paths should be 0, so that's the condition that I want to use. So the length of the room IDs should be equal to 1, and the length of the path IDs should be equal to 0. Then set the finish attributes for detail to be 1. And if it's 1, then I want to stop this calculation. So as I did for the maze creation, I would like to create some stop condition here. So let's look at the detail of the connection null node and look for the finish. And if it's 1, then the condition, the iteration, the loop should quit. Now the loop number of iterations is currently 1, but I can just increase to really high number, but still finishes after connecting all the possible connections, after having all the possible connections like this. And that looks good, I think. Okay, so this point the connection is done. Now the last step we want to do is to trim out the maze paths like these one, because some of the paths have dead ends which doesn't connect to anything. So by trimming out these paths, it will become more organic, more natural looking dungeon, procedural dungeon or roguelike dungeon, which Bob Nystrom is explaining in his article. So let's do that as for our next step. Okay, now trimming the dead end of the path is also done by using a recursive loop. So I'm gonna have to use another for each feedback loop, but this time it's a bit more easier than other steps. It's much more straightforward. So let's do that. And for each number again, and let's set the merge each iterations, change to the feedback each iterations, and then also fetch update change the for each begin method to fetch feedback. It's just directly connected with the for each end 3. Right, then the thing here that I want to change is this value, the iterations. This time, maybe there is a chance that I might not want to trim all the dead end away, because having some of the dead end would make the dungeons a bit more realistic or more interesting, as Bob Nystrom says. So in order to do that, I might want people to be able to control this number of iterations, so that they can control the balance, how much they want to trim out the dead ends. So in order to control that, let's just make some parameters for it. Okay, and let's go to the parameter interface and create an integer parameter, and I'll just name it sparse count, or trim count. Maybe sparse is okay. Sparse count. So in order to make it sparse. Okay, then I'll set the range from 0 to 100. Maybe 100 is too big, but it's fine for now. And copy this parameter to this iterations. Alright, now this step is pretty easy to do. I'm just gonna use single primitive wrangle in order to trim out the dead ends. Now the rules in order to check whether the path is at the dead end, it's pretty easy. I mean, you just have to check the number of neighbors. For example, this one, if you check the neighbors, you have like 4 neighbors, this one, this one, this one, and this one, and you can see that only one neighbor is a path or open one neighbor is a path, or in this case room, but all the other neighbors are block. So that's the condition that you can check with the number of block or number of path or room neighbors, neighbor rooms or neighbor path. In this case, I'm just I have swapped all the paths with rooms, so I'm going to count the number of rooms for each cells, and if there's only one neighboring room, then that means that this cell is at the dead end. You might want to trim it out. Trim it out means that convert it into a permanent wall, means block. So let's try to do that. So look, first of all, let's filter the primitive cell by room group, And I'll name this remove dead end. Oops, oh no, dead end. Okay, and let's check the neighbors by retrieving from the primitive attribute called neighbors that initially we have set it. We have set it initially. And let's also have a variable called room count to store the number of rooms for each neighbors. Number of rooms. And go through all the neighbors. And is check this room if the prim cells is room or not by in prim group. For each neighbors and add room count using this condition in is room. So if this is more than one, I mean if this is 2, 3, or 4, then it means it's part of the room or part of the path here. But if it's just one, then it means it's dead end. So you can just convert it into a block. So if room count is equal to 1, then change the color to black and set prim group. Room to 0 and instead prim group, set the group to block. And let's see. Now can you see the difference? This is a one step. Before that, it has dead end here, but by having one step deletion, I have trimmed out one block off. One block. I have trimmed one dead end cell here. And if I continue doing it using this iterations starting from 0, 1, 2, as you can see here, there's no dead end anymore, so this one just stops at this point, but other one, if there's still a dead end like this one, continues deleting it. Okay, so there is some weird stuff going on here. I am not sure why this is going through like this, because it shouldn't be. Because at this point there should be no dead ends for this one, but seems like it's still going to delete. Let's increase this one to see what kind of change. Okay, now that's weird. That is weird. Maybe I have set some group at wrong group at some point. Let's check by first of all delete get the block or room. Okay, I do have some weird stuff here. So I have just retrieved the room here. Delete selected. That is kind of a weird stuff. That That is weird. Okay, something must be wrong here. I think I need to change something. So after 1, that seems okay, but 2, this one also changing. That's not good. That is not good. Maybe the one I deleted before was a mistake. One group that I deleted at some point, which was the entrance and the picked connection stuff, picked connector stuff. So let's go back and edit that one. Where is it? I think it's this one, swap room, and for this, okay. Okay, I'm missing the spell here. Damn. Prim num. Okay, let's see if this corrects. No, I think it's still weird. No, yeah, I think it's still weird. Let's look at the swap room. Any weird stuff going on? Nope. I don't think so. Let's change this to a pick connector, and before that, I think I was commenting out this one, but I'm gonna retrieve this one. And let's see what would happen here. Now this is still wrong. That is because, yeah, I think this one also should be somewhere. Okay, let me pause a little bit. Okay, for the swap room where I used the is entrance here, I'm gonna change this to is picked connector, and also go back up above and change this one to is no, picked connector. Also this one is picked connector. Okay, now I am still missing something. That's for sure. Let's go back here. This should be okay. This one, I think it's okay. And this one, think it's okay. Maybe the first one is a bit wrong, probably. Maybe not. obviously this one is doing something wrong here. So let's pause this again. Sorry. Wait a minute. Oh man, some spell mistake here. But still, nothing happens. Okay. Maybe I am still missing something. Sorry for that. It's not. It's connect candidate. Okay. Now it seems to work at some, but still something is wrong here. It's weird. It's weird. Okay. Okay, I found a really stupid mistake here. So all the other places was okay, just that the first one, the connect candidate one, in the condition here, this one, the find room IDs, if the room ID is included in the room ID here, I've set it like larger than 0, but I have to do like this, because this, I mean, there 0 also mean it is included because it's just an index. And the one that retrieved from this one is the index number, so 0 is also correct. So by doing this, this one looks correct. Okay, let's try to view code from 0. The first one. Yeah, I think it's going correctly. But I do think I still need some more conditions, because if I change it to 1, the entrance doesn't change here yet. So maybe I still need to set this this connect candidate group set to 0 or this place. I'm not sure, but let's try and see how it goes. Yeah, I think it's going well. Yeah, from what I see at this place doesn't look weird. It looks good. Now how about this one? If I change the iterations going upward until some... Okay, now this one looks also good. Deleted all the dead ends and delete nothing weird. Great. This looks great. Now I might also need some stop conditions for this one, because but though this one is parameterized like this, so maybe I don't need it. So as you can see, by changing those parameters, you can kind of control the balance of how much you want to trim out the dead ends. And maybe having some dead end is good in terms of gameplay, like in a roguelike, because sometimes it happens. Sometimes you do have this kind of conditions, and looks good. Yep. Now it's almost done. I mean, 90%, 99% has been done by this. At this point, you already have a roguelike dungeon in 2D dungeon tile here already. Now the last thing I would want to do is, since I'm using a 3D software, Houdini, so maybe I would just extrude this a little bit to make it a bit more 2.5D, so that to make it a bit more prettier. And I'll finish this tutorial by the end of it. Okay. Okay, to make it as a 3D, so these are the connections which connects rooms and paths, I guess. So I would like to create a kind of simple door like material geometry in between in the entrance positions, and all the other black block I would like to make it as a extruded wall. Let's do that. Okay, so first let's create a simple geometry to visualize it as a door, but I'm not gonna like create some detail for the door. I'm just gonna use some box as a door maybe, but the half size of the cell to be a door thickness, and move this downward a little bit, like half size. And then let's color this box like red. So this will be the base shape for the door, the entrance between the rooms and path. Now, the place where I want to play, the position where I want to place this box, or I mean the door, is where the primitive cell, which has entrance group. So if I look at the primitive wrangle, there should be a group called entrance somewhere. This one. And if these are the places where I want to place this red box as a door. So, but if I just place that into those places, into those center of the cell, then as you can see, this one has a direction, like, so you also need to control the direction, which way you want to face this door to, based on the conditions. Like this one should face to left and right. This door should face up and down, so such that. So let's create some simple information for that using, I don't know, primitive wrangle, I guess. Primitive wrangle. And I'll name this entrance position. And I'm gonna filter this group by an entrance. And first of all, I'm gonna create a point at the center of this entrance primitive. So add point, and also set the point attribute, point group as entrance. This is not a primitive group, but this is gonna be a point group that I'm gonna use with the copy stamp. And get the neighbors for this entrance in order to retrieve the direction, whether it's facing left and right side or the up and down side. So get the neighbors from the primitive like this, and just get one of the neighbors. Probably there are 4. Most of the cells has 4 neighbors, but just getting one is enough. And get the position of the neighbors. And also by the position of the neighbors and the current entrance position, get the direction between the entrance and the neighbor. And also check if the neighbor is room or not. So int is room imprim group room A. Now here comes the trick. Kind of interesting trick, I guess. If is room is equal to 0, so if the neighbor is block, then just rotate the direction by 90 degrees. So make a matrix named mat as an ident, using ident, and rotate this matrix by 90 degrees. Then rotate this direction to the neighbor by 90 degrees by multiplying matrix, so that if it's facing the room, then you don't have to rotate the direction. It's just, you can just use it for normal for a point. But if it's not facing, if the neighbor was the block, then if you just rotate it 90 degrees, then it's gonna always be the room side, because it's either up and down or left and right. So by doing this, just set point at riv at pt with this direction. Okay, now use copy stamp. Okay, this color should be primitive, and copy this box into the template of entrance, and voila, the entrance box has been placed on this specific position that I wanted to have, I think. Now the next thing, let's extrude this base dungeon so that I could have a 3D looking dungeon. So what I want to do, I'm gonna use the poly extrude for this one, and I'm gonna extrude just the room group. Oops. Room, and by the size of -1, so extrude downward like this, and I'm gonna set the side group, which is this one, as a block. So these sides will be block group, so the same as the top group. And then create a color node for block primitive, and I will set the color to some, I don't know, maybe like blue color. And at this point, let's set the background to black so that I can see it more clearly. I don't like this color. Oh well. Let's go with this. And then also let's set the color for the floor, which is grouped with room color, room group. So let's create the color, another color node, and set this to room, and set this to primitive, and white is okay. Now let's combine this box with the dungeon, and voila, the door has been perfectly placed with the perfect direction. And I think this is it. This is the final output. Well, it took really long time to create this stuff since there's a lot of coding here. But the result is pretty much promising. Thanks to the evolved Nystrom, the algorithm is really great, really neat, and it was really fun implementing it using Houdini, and I think it works pretty well. By changing the X and Y grid size, changing the size of the room, maximum room iterations, seed, and trimming iterations. Maybe if I increase the grid size, the calculation might be a bit slow, but still, I think it's pretty fast enough. Oops. I mean, it's not that too slow for procedural modeling, I think. And I do love the result. Yeah, I think it's really interesting. And that's it. If you make it this far, then I'm really glad. I'm really appreciated it. I hope you enjoyed it. Especially the algorithm itself. I mean, I really suggest you look at the article that Bob Nystrom wrote. It's really a great article. I really loved reading it, and I hope you enjoy implementing it in Houdini as well. And you can download the file from the description written in this video for this video. Yeah, thank you. That's it. Thank you.